If I told you there's one single thing that all living beings on Earth have in common, what do you think it would be? No matter how big or how small, no matter what they do or what they feed on, we all do it. And more importantly, we'd all be very screwed without it. This is a very simple form of metabolism that transforms the carbon dioxide in the environment into small organic compounds that are needed to do all life activities, and even to build the body that allows us to do them. The name of this pathway is the acetyl-CoA pathway, for a lack of a more enticing name, and it basically takes the carbon dioxide from the environment and transforms it into one of the simplest organic compounds, acetate. The reason why this is such a big deal is because this can then enter other pathways that deliver more complex, specific compounds that are key to build up the set of biochemical reactions that constitute an organism's metabolism. We can think of it as the basic foundation of all the other complex and incredibly intricate reactions that make us be alive. For example, the citric acid cycle is known to be one of the most ancient pathways, meaning it has been operative in one way or another since life first appeared on Earth about 4 billion years ago. As its name says, it produces the bigger, although still quite simple, citric acid molecule from acetate. And even though this might seem easy on paper, it is one of the biggest achievements that differentiated life from non-life, because producing citric acid from simpler organic compounds is not a spontaneous process, meaning that it doesn't happen under normal conditions unless some external energy input is added. But somehow life figured out a way of doing it, and now we all make use of it. So what we're trying to do in astrobiology research is to study each step of the pathways under the conditions of the early Earth, and see if we can understand how the most ancient forms of metabolism first appeared. Doing this will allow us to understand how a similar chemical network might lead to life under different conditions in other planets, helping us to build a theory of life that is not just a collection of compounds, but also a collection of processes that create something much bigger than its constituent parts. So, next time that you see any other living organism, take a moment to think that, no matter how different we might be, there will always be something very little, but very important, in common.